Every day, websites need to decide whether the visitor is a real person or an automated bot. A malicious bot can send automated requests much faster than a normal human and can abuse forms, logins, polls, or online transactions. CAPTCHA was created as one way to separate automated programs from legitimate human visitors. CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. The basic process is simple. A human reaches a website, the CAPTCHA evaluates the interaction, and successful verification allows the request to continue. When the system decides that the visitor is legitimate, the website can allow the requested action to continue. One of the classic CAPTCHA designs asks the visitor to read distorted letters and type the characters into a form. The letters are intentionally distorted so that they are difficult for automated programs to interpret, while a human can usually recognize them. If the submitted characters do not match the expected answer, the visitor is normally asked to try again. As machine learning improved, advanced bots became better at recognizing distorted characters. That limitation encouraged websites to move toward more complex challenges and behavioral techniques. This is why modern CAPTCHA systems are no longer limited to reading blurry text. ReCAPTCHA is a more advanced service that was developed as an alternative to traditional CAPTCHA tests. One type of ReCAPTCHA presents a grid of images and asks the user to identify objects such as vehicles, trees, or street signs. The visitor selects the matching images, and the service evaluates the response before deciding whether to allow the interaction. Some ReCAPTCHA challenges show a simple checkbox labeled "I'm not a robot," but the click itself is not necessarily the whole test. The system can consider how the cursor moves toward the checkbox, along with other browser and device signals. Depending on the implementation, browser cookies and device history can also contribute to the decision about whether the visitor appears legitimate. Modern ReCAPTCHA can sometimes evaluate a visitor without requiring any visible challenge at all. The system can examine a broader picture of the visitor's behavior and interaction history and decide whether the visitor appears to be a bot. If the system cannot confidently determine that the visitor is legitimate, it may present an additional challenge such as image recognition. Some enterprise CAPTCHA systems use a score to represent how likely an interaction is to be legitimate. For example, a score close to 0 can represent higher risk, while a score close to 1 can represent a visitor who is more likely to be legitimate. The website can then use that risk assessment to decide what action should happen next. A website may place CAPTCHA protection proactively, or it may trigger a challenge when behavior looks unusually automated. For example, requesting pages or clicking links at a much higher rate than normal can make an interaction look like bot activity. The website can then require additional verification before allowing the interaction to continue. CAPTCHAs are useful, but they should not be treated as a complete solution for stopping malicious bots. Some bots can bypass certain CAPTCHA challenges, and attackers can also use human click farms to solve challenges on behalf of automated systems. CAPTCHAs can also create a poor user experience and may be difficult for people with serious visual impairments. Because CAPTCHAs are not completely bot-proof, organizations should combine them with other bot management and security controls. A stronger architecture can combine CAPTCHA with web application protection, behavioral bot detection, and continuous monitoring. There is another interesting connection between CAPTCHA systems and artificial intelligence. When humans identify difficult text or objects, those human-labeled results can contribute to datasets used to improve machine learning systems. The broader lesson is that humans are often much better at recognizing objects and patterns when the context changes in complex real-world ways. The name CAPTCHA references the Turing test, a concept introduced by Alan Turing in 1950 to evaluate whether machine behavior could resemble human behavior. A traditional Turing test asks whether a computer can convincingly imitate human behavior, while a CAPTCHA generally does the reverse by trying to determine whether a supposed human is actually a bot. So, what is a CAPTCHA? It is an automated mechanism designed to distinguish human users from automated bots. Modern CAPTCHA can use challenges, image recognition, browser signals, behavior, and risk scoring, but it works best as one layer within a broader security strategy. The key idea is simple: make automated abuse harder while allowing legitimate users to continue with as little friction as possible. Understand the mechanism, understand its limitations, and combine it with layered security controls for stronger protection against automated abuse.